Hello, hello. I would like to say from the very beginning, prepare questions. This is my present. I picked it up myself, a good book, interesting book. Now, I'm Dmitry. I'm a product manager. Oleg will help me. He's our technical manager, ML specialist and cryptography specialist. Our company develops different solutions for secure machine learning. We're going to talk about that, where it is used, pros and contras. Today, we can talk about large language models. In the context ML, we have scalability laws that say that the quality of model grows with the growing number of parameters and data. It is not very obvious. Actually, it was confirmed empirically only. The more LLM parameters we have, from hundreds of millions, then billions, now trillions, well, okay, with the growing number of parameters, with the growing number of data, models are becoming better, but there is a problem. Open data have some limits. Marked data in the internet is over. Now, the large number of data is concentrated in silos, in enterprises, government agencies, and these data, these units cannot be shared because of different reasons, because of confidentiality requirements. One more point, Internet of Things and mobile devices, devices which store huge amounts of data. The data is not easily available for model training. Access is provided to companies and corporations which develop products, develop applications. They can collect data, but third parties cannot use such data. To solve the problem of using confidential data for machine learning, in the world practice, we have several trends, and our presentation is about federated learning. But before I start talking about it, there is a question to you, to the audience. Raise your hands. Those who heard anything about federated learning. More than half. Good. Because I presumed there are fewer. Then I wanted to ask you about Android. 50 to 60% use Android in Russia, which has a smart keyboard. Gboard that uses federated learning technology. Your mobile device collects data about texts, about corrections, marked data for machine learning. And when your mobile is connected to Wi-Fi, it launches machine learning training, and the result goes to the Google Cloud. Google raises the precision of Gboard without transmitting confidential information and redistributes the workload from its server to your device. Of course, you can reject this feature, but I think few people do that. Then I'll tell you about the federated technology, how it works, and what is the place of federated learning in the overall machine learning technology. Excellent. We have the whole domain, machine learning with privacy, security, or protection, PPML, the abbreviation is used. Inside PPML, privacy protected machine learning, inside there are cryptographic enclaves and algorithmic or programmable data protection. You can read it. You heard about SMPC. SMPC in Russian is multi-layer secure calculations. They do the following. They accelerate. Well, anyway, the usual example is who is the richest person in the room without naming the amount on his bank account. In industry, there are financial results. Banks use SMPC to define the general amount on your bank accounts. There is also confidential privacy, which you add noise to data, and data with noise is further transmitted, although the quality goes down. All critical data, all technologies about generation of artificial data can also be used. The problem is the same. There is functional encryption, encryption of images, and federated learning. And also one kind of encryption I'm going to tell you later about. FedML. How does FedML work? The key feature of FedML and an important step to data confidentiality is that we do not transfer initial data. Two owners of the data have marked data sets. The federated learning process consists of several steps. There is a certain manageable server. It can be provided by the third party or by one of the two parties. It generates the initial parameters of the global model and sends it to the participants of the session. By getting the parameters, the owners start the process of model learning by stochastic tool. Then these two people send the results to the server. The server, yes, the server aggregates the local parameters. In literature, there are several methods: federated averaging, safe aggregation, and so on. As a result, the server generates new parameters for the global model, which is sent back to the devices or to the parties of the process. All that happens iteratively, and the parties get models, updated models, which are better and better for their tasks. And the final model ideally should be such as if we trained the model on a data set, although data is not selected here. In general, that's it. Now let's pass over to details. Let me tell you about the types of FedML. Types by distribution of data among the parties. The most widely spread FedML is horizontal. FedML, HFL. The peculiar feature is when the parties have data about different entities, people, transactions, anything, any lines in the table. And attributes are factors. Here, it's important to say that, well, what kind of examples we can provide? Medicine, when we have an image that is used to identify certain diseases. Text analysis, Gboard is one of the examples. Processing of table data. Then financial industry. There is a project between Google Swift and several global banks which train a global model. In the picture, you can see the following important principles of HFL. First, each customer starts training by using the same model parameters. The same parameters, that's important. Architecture, the number of layers, factors, parameters should be the same. Second, model is refreshed, and the refreshments are transmitted to the server as coefficients or gradients. It's important because next steps are different from horizontal. And third, as I said, there is an aggregated server which can be an external third-party server or installed at one of the parties of the training process. As a result of horizontal training, each party gets the same model, and you can use it. It can use it for its internal purposes. So interaction between the parties is not necessary for that. Next concept is vertical FedML, VFL. It's okay now. Well, vertical learning, when the parties have different attributes but similar entities. For example, we have telecom operator, we have same customers, Sberbank and Megaphone operators. The bank has one kind of information, telecom operator has another information about the same customer base. Vertical federated learning is used in this case. The function of the aggregated server is assumed by one of the parties. It is not an equal interaction. That's why we talk about verticality. One party is passive, the other is active. Accordingly, the active party has targets and the models and calculates the gradients. Gradients are passed over to the passive parties, which helps them to optimize all parts of the model. And the process is continued in an iterative way, and as a result, we get a model as if we could learn it, teach it on the whole set of data. I want to stress, in the vertical learning, the parties are connected. Each party gets its sub-model. Active party gets a model for its parameters, the passive for its parameter. The inference is possible only when they work together. If a customer comes to me, I start scoring him, I need the second party who is going to send its data. from its sub-model. And accordingly, if in HFL there is no such limitation, and as a result, actually, the applicability of horizontal learning is wider, and we have quite a lot of frameworks, very well-known ones. As for vertical learning, we have fewer frameworks of this kind, and as far as I know, we have few business cases, although we believe that vertical learning has good prospects. To conclude, in general, I have already told you about everything. The most important things were discussed. HFL, same entities, persons, transactions, vertical FL. No, yes. VFL, different entities, different people, different transactions, but same parameters. In HFL, it's the other way around. In HFL, we widely use cross-device, and cross-device meaning federated learning of the global model with the use of federal learning of local devices and aggregation of data on the server. Cross-power means learning of the federal model between different companies, which has information about its customer and train one federated model. Cross-device can be implemented only in HFL. In VFL, we don't have such scenarios at all. What else is important? I told you that the party gets the global model in HFL. In VFL, you get only part of the model. Yeah.
К чему, собственно, все это рассказываю?
Why do I tell you all that? It seems as if it helps you to ensure data security, but actually this is not the case. There are different kinds of attacks which from gradients and transmitted parameters can restore initial data. Such attacks are described in the literature, in the articles. I didn't hear anything about practical usage of such attacks, but in principle, they are possible. And how can we make everything secure? We use encryption. We have FH totally is encrypted and PHE. That is partial encryption. Partial encryption. We have initial data. We encrypt them. And then we work with encrypted text. Gets a certain result, and if the result is decrypted and turned back, sent back in the initial space, you'll get the same result as if you processed non-encrypted data. Another type of this encryption, it's called homomorph encryption, addition and multiplication, partial homomorphic encryption. There are methods who can do both. Full-scale homomorphic encryption. If we apply homomorphic encryption to gradients and transmitted parameters, it would be impossible to break in and restore initial data by gradients of the model. That would be impossible. And in practice, to implement such fully secure federated learning, we use homomorphic encryption.
Важно, наверное, рассказать
Now,
о бизнес-кейсе,
it's important to tell you about business
давайте рассмотрим,
cases.
как можно использовать FedML,
Let's look at how you can use
например,
FML
при построении гипотетического продукта.
when building a hypothetical product.
Например, мы
For
marketplace, у
example,
нас есть мобильное
we
приложение,
have a
которое, помимо
marketplace
всего
and
прочего,
a mobile
рекомендует
app
клиентам товары к покупке.
which
Такая
recommends
примерная
certain
задача.
products
И при этом мы хотим
to buy.
использовать
And we
LLM
want to
для
use
генерирования
LLM
рекомендаций с
to
учетом
generate
поведения пользователей
recommendations,
и
taking into
запросов по
account
приложению.
user behavior
Мы
and
как-то обучили
previous
нашу
requests
LLM-ку,
of
при этом
those
хотим, чтобы эта
users.
модель
We
управлялась с учетом фактической
taught
релевантности
that
выдачи рекламы относительно
model,
запросов пользователей.
and we want
При этом
its advertisements to be
первое,
relevant.
эту
First,
LLM-ку обучить можно только
this
на
LLM
сервере,
can be
например, в
taught
облаке, потому что она
only
очень большая и
on
очень
the
сложная.
server in the cloud because it's
Передавать исходные
large
данные
and
с устройства на
complex.
сервер очень дорого.
Initial
Нагрузка
data
на сети
shouldn't
и
be
обработка
transmitted
гигантского объема
because
этих
it's
данных
very
на сервере.
expensive.
Это все очень дорого
The
и очень
data
сложно.
volume is huge, it's
И, конечно же,
expensive,
не все
it's long,
пользователи согласятся
and not all the
передавать эти данные.
users
Как
will
раз
be ready to
FedML
send their
решает эту
data.
проблему.
FedML
Мы
solves
обучили эту
that
глобальную модель
problem.
в облаке
We
и
taught
установили в это
that
приложение. Это как раз
model,
единичка.
installed it in the cloud. It's
И
1
двойка, кажется, да? Нет,
and
еще нет.
2.
Это единичка, потому
No,
что мы
not
ее
yet.
как раз установили в
1
приложение.
only,
Дальше
because it's
действия
in the
пользователей уточняет
application.
модель,
Then
корректируются веса,
customer
модифицируются ошибки
behavior corrects the
и
model,
тренируются какие-то
minimize
локальные модели.
errors, and
Далее
train
результаты
local
этого
models.
обучения передаются
The results
агрегирующему серверу,
go
который
to the aggregation
вычисляет
server,
опять глобальную модель.
which
И
recalculates the
далее,
global
соответственно, в рамках
model,
обновления приложения эта модель
and then
опять
the application is
устанавливается
updated
в
and the
приложение.
model
И так это
is
происходит бесконечно.
reinstalled again and again
Как
infinitely.
бы, но на самом деле мораль этого слайда, она о том,
The
что
essence
выживет
of
этот
the
кейс
slide
можем по
is
факту
that
применить к чему угодно.
we can apply this
Здесь мы
case
говорим
to
о рекомендательной
anything. We are
системе,
talking
но
about
мы можем
recommendations,
делать
but
то же самое там,
we
для
can
обнаружения
do the
фрода,
same
для обнаружения
for
атак на устройстве и
anti-fraud,
так далее, и так далее. То есть,
for
в принципе, везде, где используется ML, вот
disclosing
такое федеративное обучение на девайс, оно
intrusions.
будет плюс-минус с такой же архитектурой.
All those tools will have almost the same this
Давайте пройдемся
architecture.
по сферам, чтобы приземлить
Let's look at the
конкретные примеры.
spheres
Мы
and
уже
specific
поговорили
results.
про рекомендательные системы в
We
девайсах.
talked about
Есть
recommendations,
еще такое направление, как
and there is another
data
area
monetization платформы.
which is called data
Я
monetization
думаю, что все сталкивались
platforms.
с тем, что вы от
I
операторов
think
получаете рекламу
you got
SMS-ками. Вот. То есть как это
ads
происходит
from your
внутри
operator.
операторов.
How?
Обычно, кстати,
The
это делают
operators usually
какие-то третьи лица,
have some
устанавливается
feedback
софт,
from third
который
parties.
по логам
There is
оператора
some
анализирует
software which
ваше поведение, как у вас
analyzes
там,
your
внутри
behavior.
этой системы несколько моделей.
There are several
Модели
models inside
сегментируют
that
вас,
system. The model
рисуют для вас
segments you,
по вам целевой некий портрет, говорят, что вы там
generates
любитель
your
спорта,
image,
покупаете спортивные
your
товары в таких-то
portrait. For
магазинах.
example, you
Есть
buy
модель, которая
sport shoes in such and
оценивает,
such
насколько вы
shops.
склонны к
The
совершению
model
покупки,
evaluates how
вот, и так
close you
далее.
are to the
И
next purchase,
этот
and
софт также, например,
this
подтягивает из
soft
каких-то открытых баз
takes
рекламные
data
офферы.
from open
Вот. Далее
databases,
модель,
different
например, сигнализирует о том, что
advertisements,
вы созрели для того, чтобы
and
получить
the model
оффер.
says you are ready for the
Эти
next
офферы берутся из
ad.
базы и, соответственно,
The
рассылаются вам. То
offers
есть, ну,
for the
я,
next
например,
offer, the offer is
растение
taken
Билайн, но
from
я
the
очень часто
database and
получаю эти
sent to
смс-ки,
you.
они меня очень
I
бесят,
am,
но
I use Beeline
и
and I get such offers
как бы
too often.
поставщики
I
этого
don't like it.
софта рассказывают о том,
But
что это позволяет
suppliers of
операторам
this
увеличивать
software
ARPU,
say that
average revenue per user,
operators
на 10-15%.
uh,
Ну, в общем,
can
кажется, крутая
grow
штука.
their
Вот.
RPU
Но если использовать
by
федеративное
10 to
обучение и
15%. With
использовать
federated
дополнительные источники
learning
данных для
and
обучения таких
additional
моделей,
data
рекомендательных
sources
систем,
for
я думаю,
model
что
training
такие продукты были бы гораздо
can
лучше для итоговых
give
пользователей
better
и
result
приводили бы
for
к
end
большей
users
конверсии
and for
и
operators
эффективности рекламы.
and could
Финте
raise average per unit revenues of the operator. I am talking about banks. I can tell you a lot about banks. It's all obvious: anti-fraud scoring, credit scoring. Banks even now use different data sources to predict default probability. Same with anti-fraud. They use telecom data, potentially any other data which is stored in third-party silos like marketplaces, stories in retail shops, and that might be interesting to them. Medicine, diagnostics, and forecasting, as well as monitoring of current state of your health through portable devices. It's one of the widely spread areas in horizontal machine learning. Yandex, together with the System Programming Institution of the Russian Academy of Science and Sechenov Institute, had a pilot project to diagnose heart pathology. The Internet of Things. Well, what do we have here? Actually, I can tell you a lot, infinitely, because devices generate huge amounts of data, and confidentiality of such data is a huge task. Processing, transmission of data, Internet of Things, mobile devices as part of such ecosystem it's a very important task. We have to ensure confidentiality of data and efficiency of resource usage. There are a lot of areas, prediction of road traffic, detection of broken devices, computer vision, and a lot of other things without an end. And cybersecurity. It can be used to improve enterprise solutions. For example, a company that develops products for cybersecurity and uses machine learning. These products are already installed on premise at the customer and collects data. Data about patterns, about behavior, about users, devices, network traffic, and so on and so forth. And it's logic to presume that attacks are improving, and the models that are used to disclose such attacks should also evolve. Federated learning may be very useful here. And on device, I told you about that. ML may be used to find malicious codes, intrusions. There are different types of attacks, and most of them can be detected through machine learning. Well, now, let us finalize. In the end, I would like to tell you about drivers and obstacles to this. Gartner, one of the leading worldwide consultants.
We are all familiar with Gartner, a leading consultant in technology, global leader. They have the hype curve, and as of 2024, FedML and homomorphic encryption peaked in terms of hype. Everybody is discussing these technologies. The citation rate and referencing goes up. People try to monetize it. There are a lot of scholarly publications. It's very much hyped up in the West, not so much in Russia, but globally, yes, including China. They are part of the mainstream here. Gartner analysts themselves say that the definition of the high peak is that the only one who's making money off of it are conference organizers and content publishers. That's what you have at this stage. It's a promising technology. That much is true, but it's not easy to monetize. It ensures data confidentiality by design because it doesn't transfer any data. It is scalable. I think scalability is also a part of efficient resource management. The number of data sources, that is devices, is growing. IoT, the load on servers and networks is growing, which can be mitigated with FedML. Computation is delegated to devices, which means that you don't have to invest as much in your training infrastructure. And then another point that I haven't mentioned yet, another upside of FedML is that it shortens the data drift. The path from data to model is shorter. But then there are challenges as well. The technology will require cooperation. It's a pain point, but it's not as easy to find parties that would share their data. You need a component of trust. A negotiation is needed first that will leave each party with some business sense to this arrangement. Before you launch a project, you need to have a vision of how to monetize it. Cooperation here includes deployment of software or federated learning. You can barely use any open frameworks or FedML. You need expertise in systems administration, security, and machine learning. Coordination there is a major challenge. You need data coherence, which means markup and factorization. Synchronization across those dimensions is very labor-intensive as well. As a new technology, legally it's in a gray area. It's not red. Independent opinions by lawyers state that FedML prevents transfer of personal data. So we are good there, but it's not in the green because there is no standard practice, there are no codified standards, there are no well-established products. Something to build confidence in the deployment of such systems. Then there are restrictions on compute. This means that in the vertical arrangement of FedML, inference needs to be done together, which puts additional load on all parties. Servers need to be available, response times needs to be short, and this is a relatively high bar. So the scope of application for FedML is thus limited. That is it from me. Thank you for joining. I'm competing with the weather and with lunch, but I'm glad to have you here. Open for questions now.
Добрый день. Спасибо за доклад.
Thank you for the presentation. Over here, I have some questions on security. There are some well-known attacks on gradients, gradient reversion, where you have homomorphic encryption as a defense. But if you use this sort of encryption, you can only do linear operations, as was said in the slide. Nonlinear can only be approximated with special functions. And this limits the applicability of layers, mathematical operations, and these networks for specific tasks are limited in terms of applicability. If you have polynomial functions, you are less secure without approximations, and nonlinearity is key for neural networks. My second question is about data poisoning. You have many clients. What if I'm a bad actor and I poison my data deliberately? Could you speak up?
Я понял, да. И второй вопрос
some buzz.
в том, как вы от poison атак защищаетесь от
So,
злонамеренных
defenses against poison attack, data poisoning, which can lead to backdoors in the model. If it's detection, you can teach the model to not recognize certain things. It's theoretical, but it's feasible. There is a bad actor that can register many accounts as FedML users. This can be a feasible attack. These are my two questions. Thank you.
Громче? Не слышно?
Let me take this. Homomorphic encryption. In vertical FedML, the best implemented algorithms are linear and solution tree gradient boosting. Algorithms for summation can be part homomorphic. It will be secure with the security guaranteed. You will not have to use approximations then. The models that I've listed do not use any non-polynomic operations. You don't have to multiply encrypted texts. In the horizontal model, one of the key applications is medical imaging and recognition. This would be deep ML, many layers. Activation functions will not be polynomial. This will give rise to many barriers. We'll have to approximate with polynomic functions. You have a trade-off between this and computation. It's a balancing game. So the trade-off will be in accuracy in the end. It's unavoidable at this stage. It hasn't been overcome in homomorphic encryption. But it's a big point for other methods, SMPC, for example. Not all algorithms are feasible there. You have summation, multiplication, and binary function. But compare function is challenging to implement in both. These are algorithm-level restrictions that we haven't been able to overcome yet. Hopefully we will, though. The main challenge in homomorphic encryption is the computational load, as well as runtime. Data processing is slower, and that's the key focus of research today. Poly or non-poly is set aside for later. Your second question was about data poisoning. Our presentation was, in this case, it's a bit theoretical. You're right in saying that if there is a deliberate bad actor who feeds bad data into our model, like white noise, for example, maybe they want to embed something in the model to create backdoors. In horizontal model, there are some defenses against it. At the stage of aggregation, there are ways to monitor the new updates and their coherence with the previous ones. There are dependencies and statistical analysis tools that allow you to catch a malware injection. It's not easy in the horizontal model, and even more challenging in vertical FedML. But then linear and gradient boosting in these models, where you split the node, where you compute for the best reward, you'll have noise data rejected automatically because you'll get better outcomes on real data. If you tailor your attacks to make the segregation or split harder and inject a vulnerability, you could do something like that. Currently, there is no guarantee that we'll be able to defend against data poisoning. Let me expand on this. You can have a separate model that detects poisoned data. It's on a case-by-case basis. But the gradients are encrypted. This will not work, no. I agree with part of the answer, but do you maybe have a solution? It's a well-known problem. It's on the level of approaches. We experiment with them, but there is no guarantee. Not a single approach can give you a security guarantee if the attacker is really skilled and diligent. There are attacks that can overcome current defenses. Again, it's an arms race. Defenses and attacks. No guarantees. Any other questions?
Здравствуйте, спасибо за доклад.
Hello, thank you for the presentation. A couple of questions on performance in this type of encryption and the impact of local models and local encryption on mobility, because it'll require battery power and computation. Yes, homomorphic encryption has a time and complexity tax when used for security. As for specific methods, in gradient boosting, it takes an order of magnitude more time and compute. This is a major restriction on battery-powered devices. So you have to work towards optimizations, which data to protect and which data is maybe generic and non-confidential. So you have to capture optimizations there, efficiencies. Linear models, gradient boosting only uses partial homogenic encryption. If it's fully homogenic, then the tax is not an order of magnitude, but 3 orders. It's very challenging. That's why we are saying that the vertical approach is more promising in our view, where we can merge data from large data owners. They require protection, but you don't need fully homomorphic algorithms. Scoring, anti-fraud, these applications do not require a big depth of layers or complex activations. The models there are somewhat simpler. Then protection of HFL and medical images. This would be a big tax on data volume, time, and compute. Again, you can be selective. Maybe you can localize a private section of an image. If it's a face, for example, and you want to look at the skin surface, you can protect some of the data, but not all of it. Colleagues, we're running out of time. One last question.
Добрый день, спасибо за доклад.
Hello, thank you for the presentation. As for vertical encryption, didn't quite follow homomorphic encryption and vertical model. Do you need to use the same keys? And if not, will it not break everything? If it's the same keys, what's the point? What are we protecting, the model or the data? That's a valid remark, but there is one key component that's missing. We only have target attributes on the active side. That's where gradients are calculated. They have a public key there. They send it over to passive parties and send the keys. That's where SOLs or noise is added, encryption is added, and then it sends it back with summation of data. It's then decrypted on the active side again with the private key. This is more of an issue in horizontal FedML. This would be that all participants would have the same set of open and public and private keys. That's bad. Then in some algorithms, there are ways to implement multiple keys, but it's very complex and it requires a third party to generate the keys exactly, and the keys would be dependent. You wouldn't have a unique pair for each party. The keys are dependent, there is a third party to generate them. The file requires just one secret key, it's on the active side. Nobody else knows it. That's how you secure it.
Я бы еще маленький мостик пробросил, если позволите, вот к...
I'd like to make a small segue from here to devices and overall security. Andrei Masalovich mentioned that most attack vectors are pretty simplistic and can be screened for with MLs. We believe that federated ML can be really useful. There is this data set called TON, you're probably aware. It has a lot of raw data of network traffic, telemetrics, many different devices, and more than 10 attacks. There were experiments with it, and it can be said with confidence that federated learning, on-device learning, is quite effective. It protects against 80% of standard attack vectors. So the promise for cybersecurity of devices holds.
Так, ну что, нам надо заканчивать. Мне кажется...
Okay, we need to wrap up.
Олег, тебе надо решить.
Oleg, I think you'll be picking the question. Which did you like most? I think the first one. It touched upon several aspects and highlighted the issues that we are grappling with.